Hi, welcome back to Python for Machine Learning. In this module, we will look at some data visualization libraries that are the most famous in the context of machine learning. Specifically, we'll be looking at three Python libraries, Matplotlib, Seaborn, and Plotly. If you have spent even a little bit of time in machine learning, I'm sure you are aware of these. Even if you are not aware of this, don't worry, we'll be looking at it from a beginner's point of view. So welcome to the lecture. So by the end of this lecture, you will have a fairly good idea about what type of visualizations are the most useful to be done in ML and its importance. You will have a fairly good idea about Matplotlib, Seaborn, and Plotly. These are very famous plotting libraries in Python. We will also perform some plotting such that we can explore the data set and we can try to derive insights from it. And at the very end of this lecture, we will perform something called as EDA, Exploratory Data Analysis. It's very famous, and this we will be doing on a very famous data set called Titanic dataset. So with that, let us start the lecture. So data visualization is very important, right? So if you are a business and you have another business client and you are building an ML model for that business who is your client, how do you communicate the performance of your model? How do you communicate to them what have you done? Are you going to present bunch of tables or are you going to show it visually? You have to show it visually to convince someone because humans, we have very much inclination towards visuals than numbers, right? So exploratory data analysis, as I mentioned, it's a technique where you plot various aspects of data and you try to derive insights from it even before you build any ML model. So we will do that today. Or if you want to discover what are the most important features in a dataset, which will allow you to classify that data using an ML model. This is called feature engineering. So this is also part of visualizing various features which are relevant for your data. You can interpret your models in terms of accuracy or in terms of F1 score or other parameters. You can plot confusion matrices. So this also we'll be doing. And as I mentioned, you have to present or communicate with the stakeholders. And that's a very important part of building ML models. You are building it for someone. So whether you are a student or whether you are an industry professional, at the end of the day, if you are doing something serious in ML, you will have to communicate it through beautiful visualization. And hopefully this lecture will provide you a good starting point to that. So the first library that we'll be looking at is Matplotlib. This library forms the foundation of the entire visualization aspect with respect to ML in Python. So let's start coding in Matplotlib with a very simple example. Matplotlib is so fundamental. It's like in one of the previous lectures, we discussed why NumPy was so powerful and so pivotal in Python because Python lists were very slow versus NumPy, which is primarily written in C language. It's so powerful. It's so fast. It makes the workflow of dealing with array of numbers easy, right? Similarly, when it comes to visualizations, Matplotlib is the base and many modern libraries are built on top of Matplotlib. Example, Seaborn or Pandas plotting. All of these are built on top of Matplotlib. So let's look at a very simple line plot example where we are constructing some artificial data of model loss versus epoch, and we are plotting it using Matplotlib. So let's open Google Colab, go to collab.research.google.com and start a new notebook. This will open an empty Google Colab notebook. And the first thing that we have to do is import the library, right? This is as if you are, it's not like calling a function, but libraries are pre-written and it helps your life easy. And you are just importing it for using here so that whatever functions are defined within that library, you can get access to. So I'm going to title this as Python or visualizations for ML. And the first thing is Matplotlib. So import matplotlib.pyplot as PLT. So let's do that. Pyplot as PLT. And then we are defining the data set. So here we have two line plots. So one x-axis and on the y-axis, we have to plot two things, validation loss and training loss. So what I'm going to do is like, I'll first copy this. I don't want to manually type this, which will consume a lot of time. So let's copy this and paste it here. Let's just execute the code. This will not display anything yet because you are simply importing the library and you are simply defining the data set that you want to plot. Now the plotting part, I will just put it separately. So plt.plot, and then you can say what you want to plot against what, right? So let's first keep it simple, plt.plot, and I want to do plot epochs on x-axis and training loss on y-axis. Let's see what happens here. When we run this, we see something like this. This plot is not at all good looking because it has no axis labels. It has no other information. It's just some numbers on x-axis and some numbers on y-axis. But that's okay. We will make it better. Let's also do plt.plot epochs, validation loss. Now, instead of plotting a second graph, this will plot the second line on the same graph, right? So that's what's happening here. If you want two different graphs, you can write it in two different blocks, or I think there is also plt.display. So you can display each plots separately. Let's see, plt.display. My bad, it should be plt.show. And here you can see that now two plots are coming separately. But you want both of them on the same plot. So let's plot it like this. Now, what is missing is x-axis labels are missing, legends are missing. So here there is a title. You can see that label equal to training loss and validation loss. So let's do that. So the third argument, label equal to training loss. And we can copy the same thing here and paste it. And this is validation loss. And this should add, okay, labels are not being displayed yet. Labels are just being added. Now, what else is there? There is X label, Y label, and then we are showing plt.grid true, plt.show. Okay, so let's add it one by one. So plt.x label of epochs. So X label is epochs. So what I just did now is Gemini was showing me suggestion of the next line of code. So I just accepted it by pressing tab on my computer, but you can accept it or you can code from scratch. Both are fine. But here you can add plt.x label epochs, y label is loss, and which loss? Training loss and validation loss. So they can be commonly called as loss. And when you show, okay, let's not do this first. So here you see when you mention plt.x label as epochs, it adds the x label, x-axis label. This adds the y-axis label. And only when you do plt.legend, this label, which is the legend, will be added. All right. And this is basically the title of each of these individual graphs. The top one is validation loss, bottom one is training loss in this case. Then plt.show is just to display the graph in case it is not getting displayed. I think that is pretty much it. Yeah. So here in the code that I am running, grid is also added. A title is also added. So we can add the title, plt.title of loss as a function, or rather loss versus epoch. So loss versus epochs. All right. So this is the title, and then plt.grids also we can do. So it's done using plt.grid of true. So let's add that also, plt.grid of true. So this should add the grid. I personally don't like grid that much, so I'll just remove it. So this is now the final plot. It has all the basic components: loss, epochs. These are the x and y and x-axis labels respectively, title and legends. Pretty straightforward. Now let's plot a bar chart. Bar chart is also described in the Matplotlib. So just look at here. We are calling plt.plot. Okay, so this plot function is defined within plt, and plt is imported from matplotlib.pyplot. All right. Now in bar plot, here it's instead of plt.plot, it is plt.bar. All right, fairly straightforward. So we can define here 3 classes and 3 counts. So this is like the classic iris dataset, although the counts are not correct here. It's usually 50, 50, 50. I have just modified it so that the bars can have different height. And then you can say plt.bar instead of plt.plot. And in the bar, we are plotting classes on the counts on the y-axis and classes on the x-axis. So classes, comma, counts, and C. So the classes are setosa, versicolor, virginica, and y-axis is the number of each of those classes. So these many flowers are there in the data set. So when you get a new data set, you can plot it like this to visualize the class distribution. All right, so that is also good. Yes, so here also we can add various things. So let's add plt.title, class distribution. Okay, then plt dot y label, plt dot, it was y label only, plt dot y label of count, because this is the count of number of number of items in each class. That's pretty much it. I don't think we need to add anything else. One more thing, if needed, we can do is assign different colors to different classes, but that's fine. This graph is already good the way it is. Okay, then the next thing is histogram. Histogram is for showing the statistical distribution of feature. So you can see which feature or any number, right? So if you have students in a classroom and you have the marks of those students, you can plot the distribution of marks as a frequency distribution. So y-axis will be sort of count or frequency. X-axis will be the bucket of marks, and you can see whether how many students, what's the average marks a student scored, what is the highest score, what is the lowest score, etc. So here again, we are using PLT only, but PLT.hist. But you might be wondering, why are we importing Seaborn here? Seaborn, we are yet to start officially. I mean, we'll be covering Seaborn in this lecture, but we are yet to define what is Seaborn, what can it do, etc. Right? The only reason why we are using Seaborn here is so that Seaborn has inbuilt data sets. So we can import that data set, especially this iris data set for plotting. The other option is we can create our own data set, which is independent of Seaborn. Then we don't even have to import it. But anyways, let us import the Seaborn library here. And let us import the iris dataset. So this will just import the iris dataset. Here you might be wondering, what is this DF? It's like a pandas data frame, because this dataset is now loaded as a pandas data frame. And what we can do is plt.hist for histogram. And what we can plot is, maybe there are features called as sepal length, sepal width, etc. So maybe we can plot sepal length. And we have to also define the number of bins. So let's say bins are 5, and let's see what this plot looks like. This should split the total number of total length of the sepal. So basically sepal means it's a part of that flower, iris flower, and sepal length is the length of that part of the flower. And there are measurements of so many different flowers. And here what we are plotting is the sepal length histogram. But here we have only 5 bins. So that's why this is the first bin, second bin, third bin, fourth bin, and fifth bin. And if we convert this number of bins into 15, it will look like even more thinner. And you can see that the lowest sepal length available is something like 4. This is close to 8. And the average is somewhere in the middle, like 6. If you want like petal length, you can also do that. Petal length. Petal is another part of the same flower. And here you can see petal length plotted as bins of 15 values. Let's see if we can separate it into, okay. So here you can clearly see that petal length actually has kind of 2 modes, bimodal distribution. So one set of petal lengths are all concentrated around petal length of 1 to 2. Maybe I can split into 20 bins. Let's see what happens if that is the case. Yeah. So a lot of flowers have petal length somewhere between 1 and 2. And a lot of other flowers have petal length with average value of 5. So you can see that this is like a bimodal distribution. Very cool, right? You can see this only when you plot a histogram. We can also do like plt.xlabel. It is frequency. Then plt.ylabel. Ylabel should be length in centimeter, I guess, or rather millimeter. I'm not sure. This is centimeter, I think. So you have added I think this should be frequency should be in y-axis. This should be on x-axis. So frequency and length in centimeters, and then we can add a title. I'm not adding it here. So this is histogram, fairly cool. It gives you a lot of insights about the data set. Then we have scatter plot. So here in the scatter plot, what we are doing is the example plot that you have here. It's denoting each category by a different color. So there are three types of iris flower: versicolor, virginica, and setosa. So here three different colors are used to denote those three flowers. So what we can do is here it's a scatter plot of sepal length versus petal length for different colors. So C means it creates a color map based on species, right? So this line of code, what it does is, let me copy and paste it to run it here. So plt.scatter means it will open the scatter plot, and df of sepal length will become the x-axis, df of petal length will become the y-axis, and color map will be based on species, and we are categorizing the species and we are creating a category code. So if we do this, it will create the three, because there are three species in the data set, it will show like this. We can also do one thing, df.head. I don't think this will, I'm not sure. Yeah, okay, it works. So here you can see that, or df.info. Df.info will show you that there are three, no, not yet. So df dot, we'll just print this df itself. So you can see that species has setosa, virginica, and in between there is one more called versicolor. So that's how it is. Each category has 50 data points. That's what you're seeing here, right? The categories are created based on that. If you want some other colors in the color map, you can also do that. But here you can see that color map is created based on the species value of the particular flower. All right. So this is the scatter plot. Very cool, actually. By plotting this itself, you can clearly derive a lot of insights. What is that? This flower has the highest, whatever this yellow color flower is. We can add a legend also, but let's keep it like this for now. This flower has the longest petals and longest sepal. This flower, whichever this is, has the shortest petal. But you can see that sepal length, it overlaps a little bit. This blue color dots and this green color dots overlap a little bit. So the best thing that separates this flower from the rest of the flowers is petal length. Petal length is the lowest, 1 to 2 centimeter, right? So a lot of these things you can derive from scatter plot. What if you don't add the color map? So let's say I don't have this. What happens? You see, everything looks the same. No conclusion can be derived from this. This is a useless graph, but if you have the color code, this is a lot more useful graph. All right. So there's the power of visualization, and you will be doing this for sure in machine learning. Now let us discuss about Seaborn. Seaborn is for more statistically relevant plots, and it's very much used in machine learning. So let's import Seaborn and let's plot some plots. Here, what you have is the survival distribution. So Titanic dataset is a very famous dataset where you have data of passengers who traveled in the Titanic, along with a few other information like their gender, the price they paid for the ticket, whether they were in first class, second class, or third class seat, whether they were male or female, what was their age, etc. So all of this is included in the Titanic survivor dataset. It's famously available on various websites. You can also get it from Kaggle. It's also part of the Seaborn dataset. Okay, so we can import. We can just get the dataset for Titanic from here. So df instead of df, I can call it as df1 because df is already being used for our iris dataset. So df1 or maybe df2 is equal to sns.load dataset Titanic. The reason why I'm not importing Seaborn is because I have already imported it in my code. I'm writing the code in the same Google Colab. And here we are plotting the count plot. How many ever survived are there or not, right? So sns.count plot, and it is df2. And data, okay, sorry, data is df, and on x-axis we need survived. So data equal to df2. So let's just see how this looks like. So this means you are plotting the counts of all the different features that are there, but you don't want all the features. You just want survived. So all you need to do is x equal to survived. And survived is a column inside the df2, because let me print the df2 and show you. df2 dot head. This will print the first 5 rows of df2. And you can see that survived is one of the columns. And there are zeros and ones. One means that that person survived. Zero means that person did not survive. And you can see that on Titanic, most people did not survive. So that data you can get by just plotting here. But if you look at the table, this kind of an analysis is impossible. So here you can see that around 500, 600 people did not survive the Titanic. Remaining maybe 300, 350 people survived the Titanic. All right. Then here also, again, you can add the X label, Y label, etc. So at least let me add the X label. So instead of X label being survived, I can say X label survived means 0 means no and 1 means yes. So now the X-axis label is making the data more sensible. All right. So that is the count plot. Now let's look at a box plot. So here this box plot is very much useful for looking at whether a particular feature, what was the distribution of values of a particular feature for survived people versus people who did not survive. So for example, if you look at the distribution of the ages of the people who survived versus the distribution of the ages of the people who did not survive, you can see you may get some insight. So that's what we are going to do here. So let me delete, this can stay. So sns.boxplot. And in the box plot, x-axis is again survived, because we want to see among the survived and not survived people, who has, what was the age distribution. So data equal to df2. And in fact, data should be df2 age, right? So on y-axis, this should be age. So now let's plot and see. Yeah. Oh yeah, the mistake is there are double quotes here, which is not valid. So this is the age distribution of people who survived versus did not survive. So 0 means did not survive. The average age of the people who did not survive was something like 28. The average age here also, the people who survived was also somewhere around 28. So personally, for me, there is not much conclusions that can be derived, because these two box plots are saying something similar. There were equal number of elders and children and young people, or people in this age range of 20 to 40 who did not survive. Similar proportion was also present in survived people. But there are a few other interesting conclusions. Can you conclude from this that the people who died, there was no specific age to the people who died? Like if you were a child versus if you were an adult, could you have survived the Titanic? That you can't conclude from here, because here you're looking at among those people who have not survived, what is the age distribution? Among the people who have survived, what is the age distribution? And the distribution can look very much the same if the most people who were traveling on the Titanic were of this age. Because if most of the people who were traveling on the Titanic were in the range of 20 to 40, obviously among the people who survived, they will be there. Among the people who did not survive also, they will be there. But that, then you can't conclude that if you were on the Titanic and if you were of age 5, whether you will survive or not survive with equal probability or unequal probability. That you can't say from this figure, but from another figure you can say that. So let's move on to check the next data set. So here it's a class-wise distribution. So depending on the more expensive or less expensive class, whether your survival chance depended or not on that or not. So this is a violin plot. So let me first copy this. And so sns.violin plot. And here data should be df2. So here you can see the violin plot. So P class 1 is the most expensive class. P class 2 is the second mid in between expense wise, and P class 3 is the least expensive. And you can see first of all that the fare, which is plotted on y-axis, has a huge distribution, because maybe the most expensive class, there were some super expensive seats or berths or whatever it's called, which people paid for like huge amount. Maybe this is dollars, I don't know. Maybe this was whatever currency was used at that time. So the most expensive class had prices of all range. The least expensive one was fixed somewhere, maybe, I don't know, $10 or something like that, or whatever the money that was used at that time was. So y-axis, we are plotting fare here, distribution of fare. On x-axis, we are putting P class. We can also do age and see how the violin plot looks. So this is the age distribution with respect to P class. So P class 1, P class 2, P class 3. You can see that age distribution for survived and not survived, they have this kind of a pattern. Maybe another one is, let's say, I'm just curious to see what happens if I put survived here. So let's put that and see. Yeah. So if I put survived, I mean, it doesn't, because it's a binary 0. So that does not give any conclusion. But anyways, putting age is good, putting fare is good. They are all numbers with certain range. All right. So this is violin plot. And how do you read violin plot, first of all? So here, this shows, just look at the blue part and read it, try to read it like horizontally. This shows a distribution of age where you can see that among the people who traveled in first class and among the people who survived, the people of the most of the people were of ages close to 50. Whereas among the people who did not survive, whereas in the P class 1, which was the most expensive class, if you look at the most number of people who survived, because 1 means survived, their age was maybe 35, because this corresponds to 35. So one more thing you can see is in this distribution, there is some sort of like a bimodal distribution, sort of. In the survived, look at P class 2 and P class 3, right? When the age is lesser, so here the age is like very small. I don't know why this is going below 0. It's supposed to not do that. I think the axis has been shifted. But basically, you can see that when the age is low, you might think that the kids of this age probably won't survive because maybe they can't swim or whatever. But maybe in the rescue boats, they had a higher preference, so they had a chance of survival. So here you can see this is the first mode, so majority of people of this age survived, but when there were kids of certain age, they also had a good chance of survival. So fairly interesting conclusions from this plot. And next is one of the most interesting plots, the heat map or correlation matrix. This matrix shows how each feature correlates with the other, meaning whether there is a positive or negative correlation. Based on that, you can understand whether if someone was older, they were more likely to survive or less likely to survive. So let's first plot this, and then we can try to analyze the data. So here it's df dot. So correlation is stored. We are extracting it from the data frame df.core. Actually, this df is corresponding to the flower data. So we were using df2 for Titanic. So let's use df2. And we are using heat map from SNS. SNS is Seaborn. So let's look at some interesting features. First of all, fare. How does fare correlate with survival? So fare is this row and survived is this column. And where do they intersect? They intersect here, and the correlation is 0.26. It's positive, which means fare is positively correlated with survival. The higher your fare, more your chances of survival. It makes sense. Maybe rich people were given preference on the rescue boats. Age is sort of negatively correlated little bit with survival. The older people were probably not taken care of as much as kids, perhaps. Then alone is sort of negatively correlated with survival. So alone is this row, survived is this column, because if you had a big family, you were sort of taken care of because families had preferences to get on. Maybe I'm just guessing, right? I don't know. But maybe they had preferences to get on rescue boats. If you were a part of a family, you were taken onto the rescue boat. So there is a negative correlation between being alone and being a survivor. And SIB-SP, this is called siblings and or spouses. So if you had a lot of siblings or spouses traveling with you, it had a negative correlation. And P-arch means parents of children. So that there's a slight positive correlation. If you were a parent of a child in the Titanic, you had a slight chance of survival. Like that, there are many other things you see here. But this feature, this correlation map is like a very good way to immediately understand which feature might correlate positively with what you're looking at. Then there are more complex plots like pair plots. So here you can compare features pairwise. Let me just plot it once here. This should be df2. So here you are pairwise comparing age, fair, P class, and survived. So age, fair, P class, and age, fair, P class. And we are splitting it into survived or not survived. Blue means survived. Orange means did not survive. So here on y-axis you have age, and on x-axis also what you see is age. But basically, let's just look at y-axis versus survived. Most of the people who survived had age. The age of the oldest person was close to 80, and the average age of the survived people was something like 30, 40. So you can basically read this graph and understand a lot of things. So let us look at age versus fair, right? So the age of the oldest person was 80, youngest person was probably like a newborn, and fair ranged from 0 to 600. So there was even one person or two people who paid how much? Close to 500. So this is how age and fair are correlated. Here, I think the orange color means they did not survive. I'm not sure if that is correct. I think orange means that person might have survived. I'm not 100% sure which color corresponds. Okay, it's right here. Orange means survived and blue means did not survive. So I was wrong what I mentioned here. Blue doesn't mean survive. Blue means did not survive, because blue is 0. Orange is 1. 1 is survived. Orange, like 0 is did not survive. So here, obviously, you can see that people who paid more, because x-axis is the fair, y-axis is the age. People who paid more had a higher chance of survival. Again, P class versus survival, right? So P class versus, so for example, this is age. So here in P class 1, which is the most expensive class, many people survived unless you were extremely old. In P class 3, many people died unless you were extremely young. In the middle P class, again, extremely young people kind of survived, but if you were old or somewhere kind of young, like 20 to 40 range of age, you did not survive. So these are some things, some conclusions you can derive from these pair plots. Very interesting plot, and I think if you have a tabular data set with so many features, you should definitely make these plots to visualize how your data look like. Now let us move on to the third and most important interactive visualization library for in Python for ML. I mean, it's not specifically for ML, but you can use it if you want to create interactive visualizations. That's called Plotly. So in Plotly, let me show you various graphs that are interactive. So you can import Plotly as just Plotly. It's a library in Python, very famous. So import express from Plotly. So Plotly, import plotly.express as px, and you are defining a scatter plot here. So I'll first plot the graph and show you what I mean by interactive, right? So this should be df2, and this plot might take few more seconds to load. So it's loaded here. So what is interactive here? Interactivity is when I hover my mouse, you see every individual points here. I can see the features. When I hover, it shows whether this person, first of all, this person survived or not. So here 1 means it's yellow color. So all these yellow color dots correspond to people who survived. Y-axis is fair, x-axis is age. So this old person did survive. This old person did not survive. This old person who paid so much did survive. I mean, not old, like age 40. And what else? All these yellow people in general paid a little bit more, and all of them survived. All of these blue circles are people who paid generally less, because those circles are a bit below, right? They did not survive, and you can find the individual data points here. So fairly good way to visualize data. But you can download this as PNG, but you can't directly share this because this is plotted here in Colab. This is the correlation graph. Next, 2D scatter plot. 2D scatter plot is again very cool. So here we'll be using iris dataset. So you can see Setosa, versicolor, virginica, and you can see when you plot sepal length versus sepal width, these are how the three species. So all these blue ones are Setosa, green is virginica, and red is versicolor. And here also from the legend, you can see these interactive plots are very, very cool. Then you have 3D scatter plot. This is again one of my personal favorite. I mean, the code is fairly simple. That's the reason why I'm not going through it line by line. Of course, you can check the code, but let me. Oh, I did not copy. So here it will be px.scatter. So I have modified the code. So this is the code, plotly.express. Then px is plotly.express is imported as px, and scatter underscore 3D, that's a function. And here you see the plot. This is completely interactive 3D plot. Very cool. And you can visualize. So if you are ideally presenting your data set, which involves, let's say, 3 features or 3 main features, you can plot it like this. And clearly you can see that, for example, you can separate this, which one is this? Setosa from the rest using petal width, for example. Whereas these two are not that well separated, but they are separated using some other metric. So this green and this red can be separated using petal width. So this is how you can identify features that are relevant for making certain classification. Very, very cool visualization again using Plotly. Then there are many other interactive plots in Plotly. There are histograms, there are these box plots, there are violin plots like this. Very cool. I only plotted this and downloaded it, but I don't want to showcase this as part of the lecture, but I will share the code with you. Each of them are interactive. When you hover your mouse, it shows more details of what the plot is. So all the details are not printed in the PNG, but it's interactive. So you can move your mouse and see how it looks like, what the details look like. Now, I think we can get to the last part of today's lecture, exploratory data analysis, and we'll be doing this on the Titanic dataset. So let us first load the dataset. And this is the one of the most famous datasets that people do as toy problem statement in machine learning. So the dataset is also again present in Seaborn, as you saw earlier. And what we are doing here is you are loading it as a data frame, pandas data frame. And when you type df.head, it prints the first 5 rows. If you print df.tail, it shows the last 5 rows. So this is what df.head is. It's a easy way to quickly see what all rows, what all columns exist, what all features exist. So here survive means 0 or 1 means they died or survived. P class is the class of their seat, or their coupe in the Titanic. Sex, age, siblings or spouses. So how many siblings or spouses were there? Parents or children, PRs. Fare, amount. Embarked, these are 3 different towns, S, Q, and C. Q for, I think, Queensburg or something. Cherbourg, Southampton, and Q for something else, I forgot. Class, first, second, third class. This is man or woman, adult, male, deck, etc. Yeah, Southampton, Cherbourg, Queenstown. So this is the embarked town. Yeah, so anyways, so this is the data set. Now, let us do one thing. Let's have an overview of the data set. So overview is df.info, and this will give you an overview of the data set. So there are 891 rows with survived or not survived data available, and there are no null cells, meaning that all of them are full. But in age, you can see that 714 are non-null, remaining ones are null, meaning for remaining ones, no data is available. So age of every single passenger is not available. Embarked, it is available for 889 passengers. For 2 passengers, it's not available. The deck of the passenger, again, for 203 passengers, it's available. For remaining, it's not available. Embarked, for 2 passengers, it's not available. So this is how the data set looks like. And you can see this by using df.info, not df.head. Okay. Next is basic data cleanup. So here what we do is we drop some of the columns, like deck is a useless column, embark down also we can drop. Then if missing things are there, like missing age, then we replace the age with the median value of the data set. So that's what we are doing here. Then if there is embarked as a title, then embarked we can put the mode. So if a column has embarked as its parameter, and if some of them are empty, and here in fact some of them are empty, embarked has 2 of them as empty, that also we can replace with the median value, mode in fact, and we are dropping any other rows with remaining missing values, and then df dot is null dot sum. So this will confirm the cleanup. So let me just copy paste the code and run it. So we are dropping deck, we are dropping embark down. In the embarked again, remaining, any empty cells are being replaced by the mode value. Now, if we do a df dot info, we will see how it looks like. So df dot info. So you see 891, every single one of them are non-null. So all null values are replaced with median or mean values. And you can see that embarked, this one, embark town is not there, deck is also not there. So you will not see that here. Embark town is removed, deck is also removed. So there are now 13 rows. Previously there were 15, 0 to 14, right? So 15. Here it's 0 to 12. So there are 13 rows. So 2 of them are dropped. So this is also again part of data cleanup process. Then we can perform some univariate analysis. Univariate meaning how, like if you have a passenger or if you have a data set with certain feature, how is that feature distribution looking like? How many have feature value X versus Y, right? So here we are looking at the variable called survived, and we are plotting the count of the survival. So again, count plot we are plotting. This we already did before. And here you can see that majority of the people did not survive. A minority of the people did survive. This we already saw before. Next is age distribution. This is very interesting to see, age distribution of the entire people on the Titanic, not that of survived or not survived, just a histogram plot where we are using the age column from the data frame. And here you can see that the median age is something like slightly close to 30. Then, yeah, P class distribution. How many people were there in the expensive class? How many people were there in the less expensive class? So here you can see that. So here again, you are using the count plot. So X is equal to P class. So how can you convert this into this count plot into P class? So use P class, and instead of survival count as the title, yeah, survival count only, but based on P class, then P class 0, 1, 2. And yes, Y label can be number of passengers. So here you see P class 1, number of passengers were close to 200. P class 3, which is the least expensive one, it had the most number of passengers. So this is the survival count. Next is bivariate analysis, meaning how does being a male or being a rich person affect your survival? That is what we call as bivariate analysis. This is also fairly straightforward to do in SNS count plot. So here X is equal to sex. Hue is the color based on which survived. Color will be decided based on survived or not survived. And data is the entire data frame. So here, whereas in the previous count plot, we had X and DF, but we did not have a hue to show because there is only 3 P classes are there, and 3 X-axis buckets are anyway created. But here, let's say if I don't provide this hue, you will see what happened. So you have no hue, okay? So then this simply becomes survival by gender, okay? So among the males, there were, this is not even survival. In fact, here there were total 580 or something males in the Titanic and something like 300 females in the Titanic. This does not even show the actual survival. because we are not providing how to display them. But if we provide a hue based on survived or not survived, here now you can see among the males, majority of them did not survive, minority survived. Among the females, a majority of them did survive, minority did not survive, because 1 means survived, 0 means did not survive. So this is what the power of this visualization is. So and this is telling a powerful story, right? Maybe this means that females were given preferences while onboarding the rescue boat. Then P class versus survival. So that also we can do. So we did P class versus survival. I mean, P class distribution here, but no survival. So here again, I can define a hue equal to survived. And then you will hopefully see the distribution. So here you can see that if you were in P class 1, you were more likely to be survived than not survived. If you were in P class 3, you were very, very likely to be not survived, because P class 3 was probably the least taken care of class, because they were carrying a less expensive ticket. These plots we already saw, the box plot, correlation heat map we already saw, pair plot also we already saw. So this is already something that we did. And we can also do some feature engineering, like if, for example, if age is less than 16, we can add a new column called it is a child. I mean, this person is a child or not. So here what we are doing is df. So is child is not this is not a column that exists at the moment, but we are creating it. And how are we creating it? If df of age, meaning if age is less than 16, the value of this will be true, otherwise it will be false. Similarly, total family size is total siblings or spouses traveling with you plus parents, I mean total children traveling with you, I guess. And now if we show df.head, you will see these two extra columns. So you will see one column called is child and another column called family size. So is child, yeah, the values of is child are false, 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 and the age of all of these people will be greater than 16. What if I say age less than 18 is a child? Then the category, the criteria will change, that's all. And the last one is family size, right? So family size, you see. So if family size is 1, it means there was one person accompanying this person. This person should have a name. I think this is an anonymized data set, but this person was accompanied by a sibling or spouse, but no children. But family size 0 means this person was traveling alone. So this is a example of data set, exploratory data set analysis. Now let us do the last thing, which is saving the new data. So we just cleaned up the data, we defined new columns, and now we have to save it, right? So for saving it, all we need to do is df dot to CSV. So this converts the data into a CSV file. You can name it whatever you want, and then you run this. This will be saved as a CSV file. Where will you access this on Google Colab? Click this file icon, and here you will see it. But this is a temporary file. If you close and open the Google Colab, after the runtime is disconnected, you will not see this anymore. So you have to download this if you want to keep it. And after downloading, you can open it to see how the new data set looks like. So it's being opened here. So this is the new data set. See, is child is present, family size is present. So here it is false, true, false, true. Here it was 0 in the pandas data frame. Okay, survival was just 0, 1. Remaining ones were true or false. All right, I think we are at the end of this lecture now. We have finished pretty much everything that we wanted to finish. We looked at the Matplotlib, we looked at Seaborn, we looked at Plotly, we plotted some amazing graphs. We did a little bit of exploratory data analysis, and we could derive conclusions based on what kind of plot we are making, right? So I will share the code with you, the entire code with you for this lecture. I highly recommend you to run the code. These are fairly simple codes, and try to beautifully visualize these data sets and do the same thing for more complex problems, because I'm pretty aware that Titanic problem statement is a very simple problem statement, but there are more complex ones with data sets available. So try this kind of an exploratory data set on more complex problem statements. It will truly make you very confident about attacking machine learning problems completely from the ground up. So thank you so much for listening. I'll see you again in the next lecture. Take care until then. Bye.